Notes 10.1, the parabola and the circle. I'm going to do two videos for this section, one for parabolas and one for circles. Alright, we're going to start off with the standard forms of equations of parabolas. The first one is y equals a times x minus h, quantity squared, plus k. Here are a few graphs that represent a couple of different parabolas. One opens upward. This is going to happen when your a value is positive. The h comma k, this represents the vertex of the parabola. And the x equal to h represents the axis of symmetry. And you have those same things going on here in the second graph. In this one, a is less than 0, which means a is negative. Our vertex is still h comma k. And our axis of symmetry is still x equal to h. Alright, if you need more time on this to copy this down, just go ahead and press pause for the video. The second standard form of a parabola is x equals a times y minus k, quantity squared, plus h. Notice that on these graphs, the parabola opens to the sides, either to the left or to the right. That's because y is being squared this time rather than x. So that's always going to happen when your y is squared. When a is greater than 0, or that means a is positive, the parabola is going to open to the right-hand side. When a is less than 0, or that just means when a is negative, your parabola is going to open to the left-hand side. Our vertex for both of these is still going to be h comma k. And this time, our axis of symmetry is going to be y equal to k. I'm going to choose to focus on these types of equations where the y is squared for the examples in this section. For our first example, we're going to graph x equal to y squared. Since this equation is solved for x, we're going to choose values for the y. I'm going to start off with choosing negative 2 for y, then negative 1, 0, 1, 2. Now let's substitute these values for y and see what we get for x. X is equal to negative 2 squared. which is equal to 4. So our first ordered pair is going to be 4 comma negative 2. Next we're going to substitute negative 1 for y. Negative 1 squared is just 1. So our next ordered pair is 1, negative 1. X is equal to 0 squared is equal to 0. So 0 comma 0 is our next ordered pair. X equal to 1 squared is 1. So 1 comma 1. X equal to 2 squared is 4. So 4 comma 2. Now let's plot these points on the graph and let's see what this parabola is going to look like. I'm going to start off by plotting 0 comma 0. That's going to represent my vertex of my parabola. Next I'm going to plot 1 comma 1. Then I'm going to plot 4 comma 2. Next 1 negative 1. And last 4 negative 2. Now let's connect these points. Let's make sure we extend our graph all the way to the ends of our graph. Draw arrows at the end. Let's label our points. And last, let's draw our axis of symmetry. Our axis of symmetry is going to go right on top of the x-axis. The equation of this axis of symmetry is going to be y equal to 0. If we want to find the domain of this relation, the domain would be the half-closed interval from 0 to infinity. The range would be the open interval from negative infinity to infinity. If we wanted to write these in set builder notation, we could. Let me move this over so I have some more space. The domain would be the set of all x such that x is greater than or equal to 0. And the range would be the set of all y such that y is an element of the set of real numbers, or we could also write y is any real number. If I wanted to write the equation in the standard form, I could write x is equal to y minus 0 quantity squared plus 0. This would have been another way to find the vertex and the axis of symmetry and to determine which way this parabola opens. So if we were to compare it to x equal to a times y minus k quantity squared plus h, we could see here what each one of our values would represent. A would be equal to 1. K equal to 0. H equal to 0. For our next example, we're going to graph x equal to -3 times y minus 1 quantity squared plus 5. In order to do this problem, I'm going to be referring a little bit to the problem that we just did. So the problem that we just did before, I'm just going to scroll right up here. This problem right here, I'm going to refer to this one as my basic graph, this x equal to y squared. And there's a pattern that this graph followed right here where we went up 1 over 1, up 2 over 4. So if you could refer back to this graph, that might help you when we're graphing the graph that we're going to do next. Okay, graphing this graph right here. Let's look at our a value. Our a is going to be -3. So that tells me a few things about my graph. It tells me, for one thing, that this graph is going to open up to the left. So this graph opens up to the left, to the -x side over here. It also, the 3 tells me that it's going to stretch my basic graph of x equal to y squared horizontally by a factor of 3. Also, the next thing here, it tells me my vertex. My k is going to be 1. My h is going to be +5. So therefore, my vertex, which is h comma k, so be careful with the order here, because this time the order, it's kind of switched from the other one, the other standard equation graph we were doing. So you want to make sure you write this correctly. It's going to be 5 comma 1. That's going to be our vertex. My axis of symmetry, that's going to be y equal to k. So whatever your y value is right here, that's going to be your axis of symmetry. So axis of symmetry is going to be y equal to 1. So here we have a few options. We could choose a table of values to plot points, or if we already know the relationship based off of the basic graph, how it's stretching it by a factor of 3, you can use that basic graph to help you graph this. I'm going to do a table of values for this. So let's set up a table of values. I'm going to choose this vertex to be my middle point right here. And then based off of this y value, I'm going to choose 2 values that are smaller than this and then 2 values that are larger than this. So 2 values that are smaller than this would be 0, -1, and then 2 larger values than 1 would be 2, 3. And I'm going to plug those in to the equation and see what I get for my x values. So for the first one here, I'm going to get x is equal to -3 times -1 minus 1 quantity squared plus 5. This is going to give me -3 times -2 squared plus 5. 3 times 4 plus 5 sorry, negative 3. Forgot the negative on there, so it's going to be negative 12 plus 5, and that's going to give me negative 7. Then we're going to substitute 0. 0 minus 1 quantity squared plus 5. Negative 3 times negative 1 squared plus 5. That's going to give me negative 3 times 1 plus 5. And negative 3 plus 5 is 2. I already have the vertex, so now I can go to the next one. X is equal to negative 3 times 2 minus 1, quantity squared, plus 5. Negative 3 times 1 squared plus 5. So this will be negative 3 times 1 plus 5. Negative 3 plus 5 is just 2. And the last one, 3 minus 1 quantity squared plus 5 equals negative 3 times 2 squared plus 5. Negative 3 times 4 plus 5. It's going to be equal to negative 12 plus 5. Oh, I just noticed this went off my graph a little bit here. And this is going to give me negative 7. So now let's plot these points and see what our parabola looks like. I'm going to start off here with the vertex. I always like to start off with the middle of the parabola, 5, comma 1. So 1, 2, 3, 4, 5, and then up 1. Here is my vertex. Now, if I were to use that basic graph to help me, one way of doing this is the pattern with the basic graph is it usually goes up 1 over 1, up 1 over 1 to get the next point. But because we're multiplying by a factor of 3, I'm going to go up 1 over 3. 1, 2, 3. That just happens to land us on the point 2, 2. And down 1 over 3 would be 1, 2, 3. That would be the point 2, comma 0. Okay, for the next point, the pattern with the basic graph, it went up 2 and it went over 4. Instead of 4, we got to go 4 times 3, so that'll be 12. So that'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which lands us right exactly at the point negative 7, 3. So we could have gotten it from our table of values, or we could follow this pattern that we can get using the basic graph, if you feel comfortable with that. Okay, and the other one here, negative 7, 3, I'm just going to go ahead and, sorry, negative 7, 1. I'm just going to go ahead and plot that point right there. Okay, I'm going to go ahead and erase these arrows right here that I drew to help me, guide me. Okay, I'm going to go ahead and connect my points. I'm going to label my points. I'm going to draw my axis of symmetry. and label my axis of symmetry. And there is the graph. For our next example, we're going to write this equation in the form x equal to a times y minus k quantity squared plus h. In order to do that, we're going to have to complete the square. To complete the square, first we need to factor out 3. So we're going to have x is equal to 3 times the quantity y squared plus 4y. I'm going to leave a space here, and I'm going to write that plus 13 outside of the parentheses. In order to complete the square here, I need to take this middle term here, or this middle coefficient, 4, and I need to divide it by 2. It's going to give me 2, and then I'm going to take that 2 and I'm going to square it, and that's going to give me a 4. And that's what I'm going to end up adding in here inside the parentheses. Now I need to be careful here. If I'm adding 4 inside the parentheses, right, it's not like I'm really adding a 4. I'm actually adding a 12 because this 3 that got factored out in the beginning, right, eventually you can think of it as being multiplied to each one of these terms. And when you multiply 3 with 4, that's a 12. So we actually added 12. So I'm going to have to do the opposite in order to maintain balance here. So it looks like I'm adding a 0. So I'm going to have to subtract 12 to the 13. Then this becomes x is equal to y plus 2 quantity squared, because now we have a perfect square trinomial that we can rewrite in this form, plus 1. And now we have it in this form. I like to call this vertex form because it gives me the vertex immediately. So looking at this, I can see what the vertex would be. One way to get the vertex here, the y value of the vertex, I can set this equal to 0. I get y equal to -2. So the vertex would be 1 comma -2. If I wanted to write down the axis of symmetry for this, the axis of symmetry is going to be y equal to -2. And if I wanted to the final answer for this though was this. This is what we were looking for in this problem. So I'm just going to go ahead and put a box around that to make sure that that's clear, that that's what we were originally looking for. But we are able to find a lot of other information from looking at this equation.